Hello everyone, my name is Tara Al-Amri. Me and my team are looking forward to present our graduation project, Optimization of Truck Drone Parcel Delivery using Metaheuristics research, which is supervised by Dr. Sarab Al-Mhadab. First, we are going to give you an introduction about our problem and what motivates us to work in this project. Following that, we are going to describe the problem that we are targeting. Then we are going to explain our proposed grasp approach. Following that, we are going to present the experimental setups and shows the experiment and result that we achieved, and finally, the conclusion and the future work. As we know, the COVID-19 pandemic engulfed countries and industries worldwide, disrupting businesses and forcing them to identify alternative ways to conduct their operation to ensure social distancing. Nowadays, we are seeing a drastic shift from in-person to online shopping that relies heavily on the delivery companies. But if you can remember, in the past year, the unexpected increase in shipment delivery volumes overwhelmed the delivery companies, which lead to delayed deliveries. We can solve this problem by using drones. Nowadays, drones are involved in delivery systems. Major organizations such as Amazon, DHL, and UPS are adapting and integrating drone in their delivery systems, as drones have increased the efficiency, decreased the margin of error, and comply with social distancing. However, there are multiple factors that need to be taken into consideration during delivery using drones, such as weather, drone battery, and parcel weight. As a solution, we can combine a drone with a truck to deliver parcels. So we can solve the limitation of a truck speed and the limitation of drone endurance in the same time. Combining drone delivery with traditional truck delivery introduced traveling salesman problem with drone, which is a variant of traveling salesman problem that introduced cooperation between a single truck and a single drone. In TSPD, a truck and a drone cooperate in order to visit each customer exactly once. The truck and drone depart from a single depot, performs the client service and return to the same depot. The objective function here is to minimize the time required by a truck and a drone system to serve all customers and return to the same depot. To visit a customer by a drone, the drone performs a 3-node 30, I, J, K within its flight endurance limit. Let's start in the node I, which is the launch node, visit the client in node J, which is the drone node, and meet the truck in node K, which is the rendezvous node. We can say that the drone delivery solution is feasible when I is not equal to J and J is not equal to K and K is not equal to I. Also, the time to fly from I to J and the time to fly from J to K must be less than or equal the endurance of the drone. There are some additional constraints that we are considering in our project. First, the drone does not have a rendezvous node before its delivery drone node. Second, the drone cannot serve more than one customer between the launch node and the rendezvous node. Next, my colleague Yara will explain our proposed grasp approach.
Assalamu alaikum. After initializing the variables, we will construct the TSP tour using Concord. And the output of this step is the sequence of truck node visits that represent the optimal solution to the classical TSP problem. We can then start constructing the TSP detour. And to do that, we have 3 moves: make sortie, push left, and push right. In make sortie, a node is randomly selected. In this case, it's node 3, and it's converted from a truck node to a drone node. The purpose behind push left and push right is to expand the sortie by making the truck visit more customers. With that, the expansion in push left happens towards the left, whereas in push right, the expansion happens towards the right. We then improve our TSPD solution using local search, and in our project, we have 2 local search variants: first choice hill climbing and local search with simulated annealing. In first choice hill climbing, only relatively optimal moves are accepted, whereas in local search with simulated annealing, suboptimal moves are accepted. With that, we have 2 moves to improve our TSPD tour: swap and 2-opt. In swap, 2 nodes are randomly selected and swapped. In this case, the selected nodes are node 2 and 6. Whereas in 2-opt, 2 edges are randomly selected and replaced with 2 paths. And as you can see, the selected edges are 4, 2, and 5, 0. We then check if the current solution has a better cost than the best attained solution thus far. If so, we will update the variables such that they correspond to the current solution, and we will update the loop counter. If not, we will only update the loop counter. And now my colleague Lujain will discuss the experimental setup.
Assalamu alaikum wa rahmatullahi wa barakatuh. The dataset is categorized based on the distribution type, instance size and relative track drawn speed. For the distribution type, there are two different distribution types based on how the instance was generated in the benchmark. Uniform, where the coordinates are generated independently and uniformly. Single center, where the coordinates are generated using an angle alpha and a distance from normal distribution. For the instance size, in our project, we conduct our experiment on instance from 10 to 100. For the relative track drawn speed, there are two different relative track drawn speed for the vehicle by setting the value of alpha. Alpha 1, the truck and drone have the same speed. Alpha 2, where the drone is 2 times faster than the truck. For experiment procedure, we first read the dataset and then initialize variable, and then run grasp 10 times for current instance and save the best tour and duration. Repeat from step 1 to step 3 for all 10 instances of the same type size alpha, and then compute and report the average and standard deviation over all 10 instances, and then compute the finding. At the end, discuss the result. In the model experiment, two non-parametric tests were used to check whether there exists statistically significant difference between the group. The first one, Wilcoxon test, to compare the local search variance, and the second one, Friedman test, to compare the grasp with first choice hill climbing with the rival Agatz et al. And Freitas et al. And now, next, my colleague Tagreed will explain the experiment and result.
Assalamu alaikum. Today I'll discuss the conducted experiments and our results. In our project, we conducted 4 different studies. First study was grasp with first choice hill climbing, where only optimal moves are accepted. In this experiment, we saw that the moves were not accepted often, as a result of being stuck in a local optima. To address this problem, we decided to do another experiment on another variant of local search, which is local search with simulated annealing, where suboptimal moves are accepted. Third study was comparing results of study 1 and study 2. Fourth study was comparing the outperformed local search in terms of effectiveness with rival algorithms. For all upcoming charts, the y-axis represents the tour duration and the x-axis represents the number of customers. In addition, all charts on the left represent the obtained results when truck and drone had the same speed, while the charts on the right represent the obtained results when the drone had double speed of the truck. However, in study 3, we compare the results obtained in study 1 and study 2. The following chart shows the results obtained when the distribution type was uniform. As we saw in first chart, the two local search had approximate costs on different sizes, while in the second chart, the simulated annealing had higher cost than first choice hill climbing, overall sizes. The following charts show the results obtained when the distribution type was single center. As we observed in all cases, the simulated annealing had a higher cost than first choice hill climbing overall sizes. Based on the mean of the tour duration, we concluded that the grasp with simulated annealing has worse performance to grasp with first choice hill climbing. It's possible that changing values of simulated annealing parameters will result in a better improvement. We also used Wilcoxon statistic test to confirm our finding. The Wilcoxon test was done on 16 combinations for each group. The Wilcoxon significance level was less than 0.05, indicating that the two approaches do not have the same performance. In study 4, we compared the outperformed local search with rival algorithms. The outperformed local search was first choice hill climbing. The first and second chart show the results obtained when the distribution type was uniform. When the truck and drone had the same speed, the grasp outperformed the rival algorithms on small sizes, whereas the grasp had approximate cost with rival algorithms when drone had double speed of the truck. The following chart show the results obtained when the distribution type was single center. The grasp had approximate cost with the rival algorithm either when the drone had the same or double speed of the truck. Based on the mean of the tour duration, we concluded that there is no difference between the 3 approaches. It's possible that increasing the number of iterations in local search would result in a better improvement. However, we used Friedman statistic test to confirm our finding. The Friedman test was done on 20 combinations for each group. The Friedman significance level was greater than 0.05, indicating that our approach is comparable with rivals in terms of effectiveness, while in terms of efficiency, we are slightly higher than the rivals. Now my colleague Yara will continue with you.
In conclusion, drones do indeed help in logistic transportation in many ways, such as avoiding traffic congestion, providing faster deliveries, and lower transportation costs. During the global pandemic COVID-19, many organizations and companies were forced to re-evaluate their delivery strategies in order to comply to social distancing and provide their customers with a safe and fast experience. As we saw, our approach had comparable performance with the rivals, and in the future, we plan to test our approach on all instances for TSP with drone benchmark, and we plan to investigate deeper in simulated annealing. Thank you for listening, and I hope you enjoyed.